So, page 282, we have ratios and proportions. Ratios and proportions, not much here to go over. Flip the page. What I do, okay, there's a section here that converts stuff. Okay, let's go to page 298. 298, direct and inverse proportion. Direct and inverse variation, I mean. Anybody know what a direct variation is?
Like when it's like X goes up, Y goes up, right?
Don't you just like multiply the two and then divide the one, and that's the answer to the
Y is equal to KX. Looks like this is a direct variation. Direct variation, so what is this? This is a line, correct?
C.
A line, correct, with a y-intercept of 0, right? There is no intercept here, right? And this actually is the slope. So it's going to be a line that goes through the origin. This is what a direct variation looks like. Okay, an inverse variation is, instead of y is equal to kx, y is equal to k divided by x. So this would be a direct variation. This would be an inverse variation. Okay, inverse variation meaning what? Now, what does this look like? Does anybody know what this graph looks like? Probably nobody knows this because you were shown this probably. It looks like that. Okay, it's going to look like that. This is what this is going to look like. K is going to determine how far away this point is from the origin. Okay, the larger that is, the further away you are from the origin. Okay, all right, but don't worry too much about that. That's something we talk about in Honors Algebra 2. So we will do that when that shows up. Okay, so that's that. Flip the page. Percentages to fractions, decimals to fractions, percent. Does anybody need me to go over this? Or are we okay with this? We good with this? What is in fractions? How do I convert this to fraction? To decimal? Oh, hey! Good morning.
Good morning.
This is the other guy.
Yes.
The other guy. Hi, other guy.
Hi.
Okay, so 1/4. How do I change this into a decimal?
0.24.
Well, it's 0.25, right? It's quarter, right? 25%, right? It's a quarter, right? So, right, you just take the 1 and divide it by 4, really, is all you do, really, right? All you do, right? Okay. So what is 1/5?
0.2.
Huh?
0.2.
0.2, right? What is 1/3?
0.33. Repeat.
Right? What is, do something good.
0.125.
Who said that? What's your name?
Will.
Huh?
Will.
Will. Good job, Will. All right.
The other guy.
The other guy. Anybody? Any takers?
Oh.
Right?
You got the answer first then.
Where does this come from? 1 divided by 9. 0.1, right? 9, 1, 0, 1, 9, 1, 0, 1, 9, 1, 0, 1, 0.1111, right? Okay? Did anybody take pre-algebra with me? Do you take pre-algebra with me?
Okay.
Pre-algebra, I actually taught this. I taught you guys how to convert 0.12 repeating into a to a fraction. Anybody knows how to do this? Let's go back, and we did this, right? We did this, and this was 1/9, correct?
Yeah.
So, what is this going to be? What? 1/3. Okay, you know it's 1/3, but how do you get there? Isn't this 1/9
That's a good question.
times 3? Because this guy here is this times 3? Right? So I'm multiplying this guy by 3. In other words, if I have one number, 0.7 repeating is going to be 1/9 times the number here. 0.12 is going to be 99/12. So 0.347 repeating is the same as 999,347. Does this ring a bell?
No.
Oh, Sam says it rings a bell.
I wouldn't know.
So, just know, you're obviously, I would be very surprised if you got tested in the SAT about this, okay? But realize that there is a way to make a conversion of these natures, okay? All right. So that's that. Percentages is what? Percentage is what? Nothing more than the decimal times decimals times 100. Yes. Okay, good. All right. We're good with that. Move on. Fraction percent drills. Okay, move on. Aha. Okay, so let's say that I bought a business. I bought a deli. And when I bought it, the gross sales of the year before that was, so the gross sales when I bought it was $750,000. Okay? I operated it for a year, and now the gross sales are $830,000 per year. Okay, in other words, after I bought it for a year, I ran it for a year, and during that 1 year, this is my gross sales. The year before, it was that. Now it is this. What is the percent change? How do I calculate the percent change? This is a concept that, so percent change often throws you guys into a loop because you guys understand the change part. Okay, the change part is from here, you went to here, right? So the change is going to be what? The change is this. This is my starting point. This is what I ended up at. The real question is that when I'm looking for the percentage change, now I have a choice. Am I going to put this guy underneath here or am I going to put this guy underneath here? Okay, it is always the original starting point that you put underneath here. Okay? So the original starting point is what? This guy here? So that's your percent change. Okay, this is how it's calculated. Okay? All right. What was it?
10.6.
Okay. 10.6%. All right? Okay. Good job. Okay, so that's on page 305. Page 305. Growth and decay. Did you guys actually do this in Algebra 2? You guys did compound interest?
Like we spent like 2 days on it.
Here, like,
Huh?
Yeah, totally.
2 days on it? You guys spent 2 days on it?
I remember doing something about it.
Doing
That's what I
something
was
about
talking
it.
about.
Okay.
We were talking about like buying a house.
There you go. So let's say I had $1,000. Let's say I had $1,000. And I'm going to put this in the bank. Okay, the bank is going to offer me
maybe. If maybe it's not.
12% annual percentage rate.
No, I don't. Yeah.
Yeah.
I don't know how to do
I don't know how to do it, but
Huh? Does this ring a bell?
It does.
Something over
Something.
time and then.
Okay. So let's say
Yeah, it's PT.
I'm going to put it in the bank, and the bank is going to compound it once. Okay, that means that I am starting with this. Okay, and I'm going to multiply it.
Oh, right, yeah.
Right? Everybody understand where the 0.12 comes from, right? This is the 12%. Okay? Now the bank can also offer me a compounding of quarterly. Every quarter it's going to recalculate the amount for me. So if it's 12% per year, what percent is it per quarter? How many quarters are there in a year?
4.
Right? So it's going to be what? 3%, correct?
Yes.
So I'm going to have to divide this by the quarter, but I'm going to compound it how many times? 4, because there are 4 quarters, right? Anybody got your calculator? You got your calculator? Go ahead and calculate this for me. Because originally we had what? Okay, so this is going to give me what? That's how much money I'm going to make, right? So in the end, I'm making how much money? In interest, I'm going to make $120, right? What was this?
Oh, I forgot to add the little like. Hold on.
Why did you trust her with this
What does that
responsibility?
mean?
I've had her for 3 years.
And you didn't learn.
Wait, 6th
What is it? What is it?
grade, 8th grade. It's been. Oh no. $1,000 exactly.
Shouldn't it be what? It should
Oh,
What?
I think I got like my $10 wrong. Hold on.
Yeah.
I got this.
This is what I want you to do, Natalie.
Yes.
Oh,
Third try is the charm. God, why is everyone watching this?
You're already messing up.
You forced me to do it on my phone.
I haven't done any of
Now
these
it's saying
before.
the phone in my phone.
Mr. On,
Yeah.
So I'm just like,
are you gonna send the video to all of us?
What?
The video for.
I'm gonna send what I'm gonna do is I'm gonna give the video to Jacqueline Specker, and then she will go ahead and distribute it out.
I got
What did you get?
1,125.
Okay, good. So you're gonna get 1125. What happened?
say got compounded.
You got more money. You got more money. More money is good, right? What happens if I compound this monthly? It's gonna be what?
Even more money.
You're gonna divide it by what?
12.
How many times am I compounding?
12.
And it'll be something little more than this. Okay, as a matter of fact, the banks will actually compound you up to daily. They will do calculations for daily. Okay? The problem is when you go daily, they only give you credit for 360 days instead of 365 because they're banks. That's how they work. Okay? Okay, so that's how compounding works. Okay, so this is a growth or a decay. It's a growth because I went from 1,000 to something larger, correct? Okay. I can also go smaller, which would mean it would decay away, right? Anybody give me an example of a decay? Something that decays away. Huh?
Wow, it's 12.
What?
Is it us?
Oh, yes. Anybody heard of radioisotopes? Radioisotopes, they decay away naturally, correct? Right? Where did we use those kind of things? In calculating what?
Don't we use it to calculate how old they are?
Yes. Carbon-14 dating, right? Carbon-14 dating. Everybody heard that before? That phrase? Carbon-14 has a decay rate of, if I go from 100 grams of carbon-14 to 50 grams, that's what is called the the half-life, right? Because I went from 100 to 50, the half-life. Guys, you guys are playing the game, okay? This is what you're actually doing when you're playing the half-life game. So it's a half-life. The half-life for carbon-14 is very, very long. It is 5,400 years. Okay, so that's why when you date dinosaur bones or stuff like that, you use that. Okay? Let's say that it was Natalie's birthday and I baked a cake. Take it out of the oven and I put it on the windowsill. It's going to cool off, right? That's also decay, right? Okay, all right. Population growth versus population decay, right? If I live in Austin, Texas, or Portland, Oregon, my population is growing, right? If I live in, I don't know, give me an example of a city that population is declining. Detroit, right? No, not Detroit, Oregon, it's Detroit, Michigan. All right, time out. I'm talking about Detroit, Michigan.
I mean, it's gone, so.
Okay, all right, you see what I'm saying? Okay. All right, so that would be decay. And how would it be different? If I'm decaying away 10% every year, okay, let's say that my initial population was 1 million people, and my population is declining by 3% every year, and I want to find out what my population will be after 5 years, how would I do that?
U minus. Yeah.
Okay, so it'd be 1 minus the 3%, correct? And I'm going to do this how many times? After 5 years, right? I said after 5 years, so it would look like this. Okay? Very good? All right. So that's on page 306. On the middle of page 306, it says the growth of decay rate. Okay, so the rate is plus or minus there. Now you know when it's plus, when it's minus. Okay. Average. How do I calculate an average? Let's say I gave you guys, there's 7 of you, I gave you guys a test. How would I calculate the average? This is not a trick question. Don't overthink it.
You add them all up and divide.
Add them all up divided by 7, right? That is called the average, also known as the mean. Oh, wait a minute. Mean? There are 2 other things associated with the mean. What are they? Mode. And median. Okay? Mean, mode, and median. Mean we already talked about. Mean is we add n equals 1 to k. I'm sorry. Oops.
Oh, these are
I equals 1 to n, and we get xi. We add them all together and we divide them by the number n, right? You guys seen the sigma? Have you seen the sigma? Probably not.
In chemistry.
Sigma, you guys used sigma before?
we have.
Yeah.
Okay, all right, so
Doesn't do what it meant.
x sub I, right? From 1 to n equals 7. Add them all together. Divide them by 7, right? Okay, what's the mode?
It's like the average, the mean of the lower half.
Thanks for playing. Try again. Anybody else?
I forgot.
Mode is the data point that shows up the most often,
Oh.
frequency-wise, okay? Right? So if I, 70 of your tests and I had 3 were 95, and then there was 90, something else, whatever, the mode would be 95 because it showed up the most. Okay? That's the mode. Median?
Middle number.
What?
That's the middle.
That's the best.
The middle number. So if I take all my data points and I stack them up from least to most, the one in the middle is going to be the median. Okay? Which begs the point, well, There's going to be a difference if they are even number data points and they're odd number data points, correct? So if I had a data set that ran like 6.5, 7, 10, 20, 1, 2, 3, 4, 5, 6, 7, okay, how would I find the median? Go from
You
here,
combine the two middle.
here, here. 6.5 is my median, correct? Okay. If I had another data point, okay, now I have even numbers, right? So I'm not going to actually end up at a number, right? So my median is going to be in between these two. So my median point is actually calculated like this. So it'd be 11.25. I'm not 5.25, right?
5.7.
5.25. 6. That's 11.5.
I thought it was 5.7. Yeah.
Thank you.
And
Okay. Mean, median. So this is the mean, mode, and median. This is something that you're not gonna. Well, you could be asked this, but it's highly doubtful. As a if you are a statistician, you're looking at statistics. Which is the most meaningful one for you? Mean is not the most meaningful one, and I'll show you why. The reason being is this. This is my initial data point that I start with, okay? And I find, how would I find the average here? I have 1, 2, 3, 4, 5, 6, 7, 8. So I add them all together divided by 8, correct? Which would be 7, 10, 16, 26, 46, 53. 53 divided by 8. So that's my mean, right? This is my mean. Okay? What happens if my data set looks like this? Does this change? You betcha it changed, right? I went from 20 to 200, right? So I have to add another 180 and then divide it by 8. Right? Okay? Did this guy change? My median is still the same. Right? In other words, between this number and this number, this guy here is less affected by, what do we call this? An outlier. This guy is definitely an outlier, right? 0.5, 1, 3, 5, 200. Right? Way out there. Okay? So this guy is less affected by outliers, which means that it has a more meaning to us in statistics. Okay? And you'll learn that. You'll learn that. Hello?
Wait, how do I?
Well, in my stats class, you'll learn that, is what I'm saying, in AP Stats.
Am I taking stats later?
What?
You were taking stats.
I'm taking stats.
I was placing.
You're taking AP
stats,
stats.
not data
Oh,
stats.
Wait, Riley,
Okay, so that's the average. Oh, dang it. Let's go back. I had 0.5, 1, 3, 5. I don't know. Let's say this way back. Okay? So we talked about the mean, median, and mode, okay, which is basically the three different ways of describing the center of this data set. Okay, how would you describe the range? the range of this data set is what?
19.
It is from here to here, right? So it's basically 19.5. That's the range, right? Are there any other things that we could use to decide to determine the range? You guys remember doing this?
Is it like the Q1, Q2?
It's the box and whisker plot, right?
Oh.
It's a box and whisker plot, right? So this is the minimum number of your data set. This is the max number, right? What is this guy here?
Median.
This is the median, right? Okay, this guy here is the Q1. This guy here is actually the Q3. Okay, all right. So when we do this, I am guaranteed, okay, so this is the median. So how do you find Q1? Does anyone remember how to find Q1 or Q3 for that matter? Q1 is the median of the bottom half of the data set. Okay? Q3 is the median of the upper half of the data set. Okay, which means that from here to here, I have what percent of my data? Half, 50%, correct? Here to here is what? Another 50%, correct? What is from here to here?
25.
25. Here to here?
50.
25. From here to here?
50.
50%, right? So in the box and whisker plot, within the box, you are always guaranteed to have half of your data set. Okay? So what you do here is you find another thing that we call the interquartile range, IQR, and that is nothing more than from here to here, the interquartile range. Okay? Right. And this will later on you will be able to define an actual way to say whether a number is an outlier or not. Okay? Because remember when we said this, well, oh yeah, this is definitely an outlier, right? Okay. What if it's 35? Not really sure, right? So there's a numerical way of calculating whether or not something is an outlier, and you'll use that later on. Okay, so this is another way to actually calculate the range, though, right? It is not the entire range of the data set, but it gives you something, it describes the data set to you. Okay? Okay, so that's that. Okay. So we have time for this. In data, there are two types of data. There are what we call quantitative data and what we call categorical data. Okay, categorical data. Quantitative data is basically what? What is your weight? What is, if I ask 50 people, what is your weight, what's your height? Data set would be all numbers, correct? I am 72 inches, I am, 84 inches, whatever it is, right? You'll have numbers and you can go ahead and you can average it, you can find all these other things. Okay, so that's what we call quantitative data. There's also what we call categorical data. Categorical data is your eye color, right? It's going to be brown, black, hazel, green, I don't know, whatever, right? But they're all just, it's category, right? There's no numbers here associated with it, okay? right? So how is it different that when I let's say that I had a categorical set of data, a set of categorical data. How would I graph that? What kind of graphs would I use? First of all, give me an example of a categorical data.
Eye color.
Besides eye color. I gave you that one. Besides.
Hair color.
Oh, what is it?
Be imaginative.
Favorite bird.
Favorite bird.
Would you use
Favorite radio station.
bar graph?
Huh?
Like a bar graph?
Bar graph. You can use a bar graph.
A pie graph?
A pie chart is basically mostly what we use, right? For most of the time, we're going to use a pie chart. Because pie chart is going to give you, right off the bat, in one nice view, what percent is what and what's going on, right? So in categorical data. So in categorical data, you're going to use this or bar graphs, right? Okay, what about quantitative data? What kind of graph am I going to use? A line graph, yeah.
Doesn't it also be a bar graph?
You can also use a bar graph, sure. Okay, but you're not going to use this, right? Right? Okay. Is it possible, okay, let's kind of step aside here. Is it possible for me to have a number, okay, a data set that is numbers that is not a quantitative data? Think this through. Are there numbers that are not really quantitative data? Let's say that I asked you, I take a survey and asked you what is the zip code of your address. Would that be categorical data or quantitative data? In other words, if I averaged your zip codes, right, and I said, okay, the 7 people here on the average live in zip code 9730, whatever it may be, does that have any meaning? It really doesn't have any meaning, does it? If my data set was the end number of your phone number, does that have any meaning, quantitative meaning? No. Right? So that again, even though it's a number, would be categorical data. Right? So don't fall into the trap that all the numbers are quantitative, and if it's non-numbers, it's categorical. That's not always true. Okay. You guys ready for a break?
Yes.
Why do I even ask that question? All right, I'll give you 5 minutes. No, actually, you know what? I'll give you till 9:50.